Yeah. Hmm. You are talking about this one.
Sir, resistor is not in parallel with capacitor when
Okay.
that is the case.
Okay. Now, what is your out voltage equation? Is that output voltage equation is
Sir, how will output reach to VDD or
mm,
minus VDD?
okay. So this is the V reference. So if I say the VI minus V ref upon R is equal to V ref minus V out upon 1 by CS. Okay, VI minus V ref on R equal to V ref by CS minus V ref by CS. VI dt minus V ref minus 1 by RC integration of V ref dt is equal to the VI minus VI. So this minus this plus and this plus. Okay, so this is the equation. Okay,
Sir, how do we get this third equation, the final one?
uh, this equation is okay. Now we are simplifying this equation, so we multiply. This is the divide, so we multiply 1 by CS. Okay, now with the 1 by CS, we are taking that 1 upon S is basically the integrator. So 1 by RC integration of VI dt. Okay, this particularly VREF when it is coming this side, so it become a minus VREF. And this particularly VREF is what 1 upon RC integration of VREF dt. Okay, and that is the minus V out, minus V naught. So when I take minus, so this one, so this minus, this plus, and this plus. Okay, now if you say that VI is 0, okay, no input voltage is applied, so this term will be 0. Okay, so the V out is what? Vref voltage plus 1 upon RC integration of Vref dt. Okay, and this is the factor. This is a factor that will be increases with time. Okay,
Sir, like, but it is a DC voltage, so how is it increasing with time?
it is. I think you are familiar with the voltage doubler or voltage multiplier circuits. voltage doubler or voltage multiplier circuit. Initially, that for example, this is the Vref. Okay, we are providing this is the zero. Okay, so this Vi will be zero. Okay, so Vref voltage will be there. Okay, now due to Vref voltage, the current that is passing from this circuit. Okay, so this particularly capacitor will store the charge. Like for example, it will be charged with the Vref voltage. Okay, the first case. Now again, when you apply the Vref voltage, Vref is continuously apply. So this Vref voltage and this V capacitor voltage, it will be provided with the two Vref voltage, and okay, so our voltage will be increases. Now after some times, the capacitor will charge with the higher voltage of that one Vref voltage.
So capacitor will go to 2 Vref.
Output voltage is 2 Vref.
So sir,
Okay.
how will
Now,
capacitor increase?
now second thing is that this particularly Vref voltage will be having a gain. Okay, this integrator will be having a gain. Due to this gain, the voltage is also increases. 1 upon RC is the gain factor. 1 upon RC is the gain factor. Here, if you see that this one, or because of the capacitor of R and C, if Vref voltage will be added, Vref voltage will be added. So this particularly overall voltage will be increases because of the gain as well as because of the two voltage source. One is the capacitor as a voltage source. Second is the DC voltage that you apply at a voltage source. Yes, so there are factor. One factor is basically if you apply the Vref voltage, so it is a non-inverting terminal. So this is due to this one, we have a gain. We have a gain factor. Okay, this is the first thing. Second thing is that when you apply the DC voltage, due to this DC voltage at the non-inverting terminal, your capacitor is also charged. Now that capacitor also contribute in the output voltage. So your Vref voltage will be increases. Okay, now it will be going, how it will be going slowly, because this capacitor will be charge and discharge. If I remove the Vref voltage, so this capacitor will be discharging across the resistor. Okay, so due to the charging and discharging, it will be glow. It will be increase, then decrease, then again increase, then decrease, then again increase. So in this way, it will be going to the slowly toward the completely full charging, full basically voltage.
Yes, sir. Sir, and the gain is because this is a negative feedback, like some voltage is
This,
increasing at output, that
yeah.
is coming through
If
capacitor.
if Vi is zero, so we can say that this particularly is the non-inverting amplifier. If Vi is zero, because the Vref voltage will be having a behave as a voltage source. Okay, so it will be as a non-inverting amplifier. So what is the gain of non-inverting amplifier? Okay.
Yes.
Any other doubts?
Sir, two doubts in practice assignment of week 6.
Yeah.
Question number 5 and 6.
Question number 5 and 6. Just hold on. Mhm. Analog electronics. Week 6 na? Week 6
Yes, sir.
practice
Week
assignment.
6. Yes, sir.
Okay. Yes. Yeah. So in
Six.
question number 6. Okay.
Question of 5 and 6, sir. Both.
Okay.
5 means.
Yeah. What is your doubts? For the same circuit. Okay. So first of all, what you have to do, you have to take a transfer function of this one. Okay. If we are talking about the Vi upon V naught, so Vi upon V naught, what is Vi upon V naught? Yes, what is Vi upon V naught? Have you know that how we solve this type of question?
No, sir. That's the main problem.
Okay. So then question number, how you solve the question number 3?
Question number 3 and 4 is directly formula base.
Okay. So directly formula base. Then 5 already you know the formula.
Yes, sir. But it's not giving the correct answer. Here the answer is 0.05, but I am getting 0.39 something.
Hmm. So can you tell me the formula because actually I have to solve it otherwise. What is the V naught 2 upon V out?
So V naught 2 upon Vi equal to 1 by RC1.
Wait a minute. V naught 2.
First, VO1 equal to minus V in by SRC1.
Which one you are telling? V naught?
1.
V naught 1 upon Vi. What is the value?
1 upon SRC1.
Was of 1 upon S or C1. Only this one.
And VO2 equal to minus of VO1.
Yeah, so V naught 2 upon Vi is equal to minus 1 upon S or C1.
Hmm.
Okay. Now, if we calculate the magnitude of this one, so it becomes a magnitude of V naught 2 upon Vi is 1 over omega R C1. Okay, so that is omega is 2 pi F into R into C1. So 1 upon 2 pi F is 200 kilohertz. F is 200 kilohertz. Yeah, 10 and 0.1 microfarad. 10 into 10 raised to power 3 into 0.1 into 10 raised to power minus 6. So these two are cancelled out. These two are cancelled out. So 1 upon 400 pi. They are cancelled. Then divided by 400 divided by 5. It is 0.000795. Oh, that is okay. The answer is 0.000795.
So it is VO2 upon VO1 equal to -1 upon SRC. Nice, this problem where we have written the solution
V naught 2
is equal to minus V naught 1.
minus V naught 1. No. So
Yeah,
what should I do? V naught 1 upon Vi is 1 upon SRC.
yeah,
Okay. So if I put a V in place of V naught 1, if I put a V naught 2, so it is a minus V naught 2 upon Vi is equal to minus 1, 1 upon SRC 1.
mm,
So V naught 2 upon Vi is minus 1 upon SRC.
so can you please explain the concept of this?
Okay. So basically, answer is okay. Any doubt? So it is a
What?
0.000795. Yes, who asked the question? Answer is okay.
Yes, sir.
Okay.
No, that doesn't agree with the system answer, sir.
Yeah, system answer is okay. Hmm. Correct answer is 0.000795. So now if you see that there are three particularly operation amplifier is used. Okay. So first of all, if we see that last one, if my V out 2 is the input and V out is the output, so that particularly third one will be behave as a integrator part. Okay.
Yes, sir.
So third one is basically the integrator. So what is the output? So if we find the relation between the that one, so V naught 2 upon Vi is nothing but 1 upon, sorry, V naught 2, sorry, V out upon V naught 2. V out upon V naught 2 is nothing but 1 upon S RCS1. Okay. And R, if I say that this is the R2, I just copy paste, copy image, control V. Okay, so it becomes a, if I say this is the R3 C3, so this output is equal to the R3 C3S. Okay, that is the simple integrator part.
Yes, sir.
Now, if we go with the second stage, so if my out input is the V naught 1, output is the V naught 2, so basically it is
Minus V naught 2.
V naught 2 is nothing but V naught 1 minus RF by R1. Simple, it is a non-inverting amplifier. Okay, and RF and R1 value is both are equal, so we can say the V naught 2 is equal to the V naught 1. Okay, Now the main important is the first one. So add this one. Okay. So if I draw the first circuit, so it becomes say one resistor, operation amplifier, negative, positive. Across this one we have a one capacitor with this one resistor and one more resistor. That is a V. Okay. Now your resistor and capacitor both are in
Parallel.
parallel. So we know that these two particularly is the in parallel. So it is the R C. This is the R2 RX. We say that it is RX. Hmm. So this is the R in. V in. The voltage at this point is 0. So V in minus 0 upon R in is equal to 0 minus V naught upon what. This is the important.
RX parallel R parallel C.
Yeah, RX parallel with R parallel C. Okay. So first of all, if we take the parallel combination of these two, so it is a R into 1 by CS upon R plus 1 by CS. So it becomes a R upon 1 plus RCS. And now this one is again with parallel with RX. Okay. So RX upon 1 plus RCS upon R plus RX plus RRXCS upon 1 plus RCS. These two are cancelled out, so it becomes a RRX upon R plus RX plus RRXCS. Okay, and if I divide the RRX, so it becomes a 1 upon R plus RX upon RRX plus CS. Okay, and what is this? This is the parallel combination. So 1 upon R parallel with RX plus CS. So it becomes a 1 upon R parallel with RX plus CS. So V out is what? Minus V in by R in 1 plus R parallel with RX plus CS.
So in this question, R parallel R and Rx is equal to 10.
Yeah, R and RS both are 10. Hmm. So after that, I think you just put the values and calculate the.
Okay, sir.
Okay.
Answer question
So,
number 6.
question number 6. The same circuit. Okay, for the given circuit, the magnitude of output voltage is what if the input voltage is 2 sine 1000 pi t. So now in this case, we know the frequency also. Okay, the frequency is what? Omega is, if you are talking about the omega, so omega is 1000. Okay. Yes.
Yes, sir.
Similar question, the previous one. If you solve the previous one, the similar question, this one. Now here we given the omega value. Omega value is 1000. Now put the value of omega and calculate the output voltage.
In terms of VI.
VI, yeah, in terms of
In
VI.
terms of V.
We will calculate the magnitude, na?
Yeah.
V out is basically the, if you are calculating the V out, so V out is either the sine or cos term is there. Okay. And if you calculate the magnitude, so maximum magnitude for sine and cos term is 1. So only
Hmm.
the amplitude of that particular sine and cos term will be the magnitude of output
Yes.
voltage.
And omega is equal to 1000.
Omega is equal to 1000. Can you solve it now?
Yes, sir. Thank you, sir.
Any other doubts? Yes, any other doubts?
So which kind of particular problems will be there in quiz 2?
In quiz 2, one problem with the week 8, one problem with the week 7, and one problem with the week 5 and 6. So only three problems are there.
Each of 10 marks.
Yeah, with subparts. Okay.
Okay, sir. And the difficulty level is quite higher from quiz 1, no, sir?
Yeah, difficulty level is higher. I one more thing is that I just prepare some questions. I think that is basically from week 1 to week 4 part for the practicing. Okay, I will upload it today either on the G Space, and then for week 5 to week 8 some practice question I will create and will be upload till evening. Okay, that is in the process. So I will create that one, and then after that I will upload it. because someone in the previous class says that, sir, can you please give us some more problem statements, so basically we can solve it and practicing it. So week 1 to week 4 I just create a 8 9 to 10 questions. Okay.
Okay, sir. And one more thing, the analog lab deadline is still 11th of March.
Hmm. So
What
what
should I do?
happened?
So, will we have to start the lab?
Yes, I think TA is also included in the group, so you just ask them and basically tell them that can you please arrange the session for us. You are familiar with the LT Spice because I already asked the support team to basically create a session, but I don't know. Mm, so
The majority
in
of
the group,
students still not, yeah, brought the kit, the components for lab.
mm, you can do one thing is that till 11th you complete your LT Spice simulation. Okay.
Okay, sir.
Probably the date will be extended, but I am not sure about it one. So you just do one thing is that you just start this your LT Spice simulation, because your LT Spice simulation is done. I think it will be hardly take a 1 or 2 hours to complete your breadboard circuit. The problem with the LT Spice only. Someone writing in the chat. Yeah, yes.
Sir, where we need to submit it? Is there any G form link or
Yeah, one G form will be shared with you. Okay, and in this G form, I already tell you that you have to basically create a 3 files. Like just in the I just tell you in the your Google Drive, create a folder of analog electronics lab. Okay. Now in this analog electronics lab, you just create a folder of week 1 to week 6. Week 1 to week 6. Only 6 experiments are there, so week 1 to week 6. Now in this week 1 folder, you have to upload 3 files. One is the LT Spice simulation. One is your breadboard image, and third one is a complete video with this explanation. A video with explanation. And in this video, I think you are aware that similar to the electronics lab, you have to show your ID card also. Show your ID card. Okay. So you have to upload these 3 files in this folder. Now on this basically Google form, you just paste the link of this folder. Okay. You just do the setting that anyone can access with the link. Okay. I think you are familiar with that one. So when you go to the Google is okay, when you go to the any of the folder, okay, School Connect program. So when you click on the share, there is a share. After that, just copy link, and from the restrictions, you just select that anyone with the link. Okay, and done it. Now just this particularly link you have to paste in a Google form. Clear?
Yes, sir. Thank you.
And sir, what experiment we have to do in the offline lab sessions? Is there
Uh,
something new experiment or all this?
that will be the particularly suspense for you. Okay. So when you are coming for the offline lab, we will tell you.
What sir, give us some hint so that we can prepare for it.
Before the lab, we will inform you. Okay, when you are coming for the lab, I think your lab is on last week of the May.
Yes, sir.
Okay, so in mid of May, we will inform you. Okay.
Okay, sir.
Anything else?
Will the lab viva be scheduled?
When the lab viva will be scheduled, the lab viva will be scheduled. I think after 2 or 3 labs, we will schedule a lab viva.
And what we need to do in that lab viva?
We have asked the question related to the experiment to identify that you done this experiment by your own or you are taking from someone else. Okay.
Okay, sir.
We ask some question on the basis of that one. We identify that you basically simulate that particularly circuit or implement the circuit on a breadboard by your own or you are taking from.
Sir, can you explain this ramp generated circuit once on the lab?
RAM generator. Simply, for example, if we are taking a square wave, okay, as an input, okay, and that particularly square wave will be given in the integrator of any operation, and that particular integrator will be designed with the operation amplifier. So, what is your output? If we have a, this is my input. Okay, and we give this input in the integrator. So, what is my output? You are aware with the signal system? Okay. If I take this particular signal as a UT signal with a duration of 0 to t. Okay. So what is the integrator of UT signal is? What is the integration of the UT signal is? Any idea?
T, sir.
T, that is the basically the ramp signal. Okay. UT signal integration is the ramp signal. Okay. So for 0 to t, it will be the T. Okay. Now from t to 2t, I just consider it as a minus of UT. Signal is the in the positive direction, but with the negative magnitude. Okay, minus of UT. Now integration of this one is minus RT signal. again UT signal, minus UT signal, and again UT signal, and so on. So it is a RAM signal, RAM generator.
Yes. Sir, and how is this square wave coming?
The square wave is coming. The square wave is coming from the, I think you can take from the ADML kit. Just wait a minute. I just go with the experiment. I have not.
Sir, there is one collector also, that is.
Just give me a second. Yeah. Okay, so if you see the circuit, so first circuit is your integrator. Okay, where you can create a R and C. You have this particularly comparator circuit. Sorry, integrator circuit where you have a R, and with respect to this you have a C. Okay, if we provide a square pulse here, we are getting a this signal. Okay, now the thing is that how from where we are getting the square pulse. So either you you get the square pulse with the ADML kit, square wave generator, but in this particularly experiment, this square wave will be coming as a feedback from some other circuit, from the output of this operation amplifier. Okay, and what is this operation amplifier? This operation amplifier is nothing but a comparator circuit. Okay, so it will be the R1, R2, and VCM. Okay, now what is the VCM? VCM is that it is a VDD voltage R and R grounded. At this point we are getting a VCM. Okay, so if I VDD voltage is 10 volt, so what is the VCM? 5 volt. Okay, now VCM is 5 volt. Now the thing is that if I use this particular circuit with the positive feedback, so in the case of positive feedback, either it will be used basically in the positive feedback, it will be used as a comparator. How it will be compared? If V positive terminal is greater than V negative terminal, what we are getting? We are getting a VDD as a output. Okay, and if V negative terminal is getting a V greater than V positive terminal, we are getting a minus VDD output. Okay, so we have only getting the two particular voltage. So one is the plus VDD and one is the minus VDD. Plus VDD, minus VDD. So on the basis of this voltage, V positive voltage, if V positive voltage is greater than VCM, VCM is constant, that is a 5 volt. VCM is constant, that is a 5 volt. Okay, if VDD is 10 volt, so VCM is 5 volt. So if V positive is greater than 5 voltage, we are getting a VDD plus VDD. And if Vm is less than 5 volt, we are getting a minus VDD. Okay. Now what is V plus voltage? Now what is the V plus voltage? V plus voltage is the basically a ramp signal. This is my ramp signal. Now with this ramp signal, I just mentioned that this is my 5 volt. This is my 5 volt. So if V plus voltage is greater than 5 volt, we are getting a plus VDD. So for this duration, we are getting a plus VDD voltage. Okay. And for this to this, it is a less than, so we are getting a minus voltage. Again, from this to this, we are getting a plus voltage. From this to this, we are getting a minus voltage. Again, from this to this, we are getting a plus voltage, and so on. Okay, so with the help of ramp signal, you are getting a square pulse, and with the square of square pulse, you are getting a ramp signal. Okay, now the duty cycle is dependent on the voltage. Duty cycle is dependent on the voltage. If I consider that my ramp signal voltage is 0 to 15, okay, if I consider my ramp signal voltage is lies from 0 to 15, so the VCM voltage 5 volt voltage is here. It is a 1/3, so it is a here. If this is the here, the duty cycle is changed. Why duty cycle is changed? Because it will be off for this part. Sorry. So it will be off for only this duration, and it will be on from there to there. Okay. So let's write it down. So it will be off from here to here, and it will be on from here to here. So basically, on time is increased and off time is decreased. So your duty cycle is changed. Okay, your duty cycle is changed. Clear? So this is the related about the week 1 experiment. Just any doubt? Just any doubt now? Yes. Any doubt, please ask. So no doubt?
So next week can we have some revision sessions for quiz 2?
Yeah, from the next class we start the revision session.
Just problem solving, sir. Maximum
Excuse me,
problem
sir.
solving.
Okay, so before that one, I will share till today evening the problems related to the week to quiz 5 to quiz, sorry, week 5 to week 8. Okay,
Yes,
you
sir.
just solve that one, and then if you are facing any issues, so we will discuss from the next class.
Is it like a mock test?
No, not a mock test. Mock test is different. It is only for the practicing.
Okay, sir.
Yeah, yes, Vishal.
Sir, can you please upload the handwritten solutions?
For
I mean, till now you have only uploaded like it is
okay,
only five.
week 1 to week 4 is uploaded. Week 5, 6, 7, 8 is remaining. Week
Even
5,
five
6,
is
7.
uploaded.
Okay, 5 is already uploaded. 6 and 7 is remaining.
Yes, sir. Even okay, so we have
Okay, so I will do that one.
and if
Okay.
possible, please do the practice solution also for week 5 because the deadline is of year 2026. So I can't see the solution
Uh,
answer.
practice solution.
Yes, sir.
Okay.
Because the and the practice set the deadline it shows for year 2026 and until we reach the deadline it won't show the answer.
Okay.
Yes, sir.
Week 5, wait a minute. Hmm. Week 5 practice assignment. Okay, that is the 4th for 2026.
Yes, sir.
Okay, so I just upload that.
Yeah.
Yes, Alkesh.
Sir, can you please suggest some books for practice?
For the practicing.
Yes, sir.
Hmm. Okay, so I will just give you 2 or 3 names. One is the you can use the Sadra and Smith microelectronic system by Sadra and Smith. You can refer this one. Okay, I just share one or two books with you. Okay, that I have. Okay.
Yes, sir.
Yes, sir.
In the next lecture or today itself?
No, today I just upload on the Google G Space.
Okay, okay, perfect, sir.
Okay, sir.
Anything else?
Nothing, sir. Now.
So, I just upload one book. One book I have already shared. Yes, so I have shared 3 books in the G Space. You can refer
Okay,
this
sir.
book for the problem solving. Okay.
Thank you, sir.
Yeah. So yes, thank you all.
Thank you, sir.
Sir.
Thank you, sir.